This is Mrs. Wong here. We'll be going through the worksheet given last week during FGC. This is for Chapter 10, Trigonometric Ratios. For question 1, they want us to use the right angle triangle ABC to find the values of the following. So the hint given is to use Tuakaso to help you. And the reminder that you do not need to evaluate the values of the angles. Okay, so for the first 3 questions, they want us to find the sine of angle A, cosine of angle A, and the tangent of angle A. So tangent, sine, cosine, and tangent of angle A over here. So I will first need to label the sides of my right angle triangle. So AB is the hypotenuse. If the reference angle is at angle A, then AC would be the adjacent and BC will become the opposite. So that should help us find the values of the sine, cosine, and tangent. To find sine of angle A, we need to take the opposite over the hypotenuse, which is 8 over 17. To find the value of cosine A, we need to take the adjacent over the hypotenuse, which is 15 over 17. And to find the tangent of angle A, it will be the opposite over the adjacent, which is 8 over 15. Now, for D, E, and F, they will want to find the sine, cosine, and tangent of angle B. So now my reference angle has changed from A to B. So we need to rename the sides of the triangle. The hypotenuse will stay as AB, but the adjacent and the opposite would now change because my reference angle is now B. So the side BC will now be the adjacent. The side AC will now be the opposite. So I'll do the same using Tuakaso to help us find the values of sine, cosine, and tangent of B. Now, if you have not tried this question, please pause the video and try the questions first before you continue to check your answer. So here are the answers. We'll go on to question 2. Question 2 wants us to find the value of the unknown in each of the following right angle triangles. So the hint given is to identify the correct trigo ratio to help you. Okay, so you have to identify whether you use sine, cosine, or tangent of the given angle. So for the first triangle, my unknown x is the hypotenuse. The reference angle given is 48, so 6 cm would actually be the opposite. So in this case, I will have to use sine of 48 equals to opposite over hypotenuse to help me find the unknown x. Okay, so once we have this, I need to do some manipulation. So I'll be bringing the x over using cross multiplication. So x sine 48 is 6. Then I only want to find the value of x, so I will bring sine 48 over. So you key this in to your calculator to find the value of x. We'll go on now to part B. So same thing, I would label. I have the hypotenuse. The reference angle is y, so 12 cm is the adjacent. So with A and H, if you look at your Tuakaso, we will now have to use cosine. So cosine of y would actually be 12 over 18. To find the value of y, we will take cosine inverse, and you should be able to get your answer. We will now go on to part C. So I label. I have Z, so 27 will be the adjacent, 51 will be the opposite. Okay, so the trigger ratio that makes use of both the opposite and the adjacent would be that of tangent. So tangent Z is opposite over adjacent. To find Z, I will take tangent inverse. For question D, it's a little bit more complicated. There are more than one unknown. Okay, so we will have to make use of what we have first. I'll label the hypotenuse. Okay, so if 31 degree is the reference angle, 8.4 cm would then be the adjacent, and xcm would then be the opposite. Now let's do this step by step. We will now focus on one of the unknowns that we want to find. So if I want to find the length of the opposite, which is xcm, so I have my adjacent, I have the angle, so I will make use of the trigger ratio tangent. 31 is my opposite over adjacent. So x is actually 8.4 tangent 31 degrees. This will help me find x. So I round off my answer to 3SF. Now to find y, I do not need to make use of my x because I have sufficient information. So I'll make use of the cosine of 31, which is the adjacent, over the hypotenuse, then do my algebraic manipulation. So y is 8.4 over cosine 31, which is 9.80, corrected to 3SF. Now for this part D, if you choose to use the value of x to help you find the hypotenuse, you can also do so, because I can make use of the two shorter sides of the right angle triangle to find the hypotenuse. We'll now go on to the next question. Okay, question 3, we have PQR as a triangle and PT perpendicular to QR. They want us to find the length of BT. Oh, sorry, it should be PT here. Okay, error. This should be PT. So the hint given is that we need to identify the right angle triangle that we will use to find the length of PT. Okay, so there are two right angle triangles here. Which one has sufficient information for us to find PT? Then for QT, for part 2, later on we have to see what information we have to help us find the length of QT. So let's focus on PT first. Okay, to find the length of PT, I'll make use of triangle PRT, and I'll make use of Pythagoras theorem to help me find the length of PT quite easily. So I have the length of PT. With the length of PT found in part A, I can actually make use of the length found. Okay, I'm using the phi SF value to help me find the length of QT, because I have the opposite. I want to find the length of the adjacent given the reference angle here. So for part 2, I will make use of tangent of 71 degrees is opposite over adjacent. Okay, so QT is this value here, and I'll round it off to 3SF. Now notice that I have written the 5SF answer because there is still a next part, and I might need to use the value of QT. If so, I'll make use of the 5SF value. Now, part B wants us to calculate the area of triangle PQR. So I will take half times base times the perpendicular height PT here. So the area of triangle PQR is 18.5 cm square. So this will be my answer for question 3. We'll go on to the next question. For question 4, the diagram shows two right angle triangles, ACD and BCD. Given CD is 24 cm, angle ADC is 30 degrees, angle BDC is 20 degrees. We need to find the length of AB. Okay, so the hint given is that we cannot find the length of AB directly. So we have to make use of the two right angle triangles to find the length of AC and BC first. Then I would subtract the length of BC from AC for me to find AB. So if I were to label the sides of my triangle, okay, so AD and BD, they are respectively the hypotenuse. Because the reference angles given are at D, so CD would naturally be the adjacent, and AC and BC would become the opposite. So for this question, I'll want to find the length of the opposite given the length of the adjacent and the given angle. So I'll find the length of AC first. To find the length of AC, I'll make use of the larger triangle. So making use of the trigo ratio tangent, okay, I will have AC is 24 tangent 30. I'm not in a hurry to evaluate this value because I know that I'll need to do my subtraction later. So I'll keep AC as this and I go on to find BC. Okay, so BC is 24 tangent 20. After I have these two lengths, I can now subtract BC from AC to find AB. So AB is AC minus BC, and I get 5.12 cm. So this is my answer for question number 4.